Hello students. So after knowing about the basic framework of linear programming problems, now we will understand their formulation, that how to formulate linear programming models. So let us consider a very simpler problem. Commonly we call it diet problem. Okay. So a person wants to decide the constituents of a diet which will fulfill his daily requirements of proteins, fats, and carbohydrates at the minimum cost. The choice is to be made from four different types of foods. The yield per unit of these foods are given in the table 2.2. So from here we can see that food type 1 consists of 3 units of proteins, 2 units of fats, and 6 units of carbohydrates in its 1 unit, and per unit cost of food 1 is 45 rupees. Similarly, food 2 contains 1 unit of food 2 contains 4 units of proteins, 2 units of fats, and 4 units of carbohydrates, and per unit cost of this food is 40 rupees. Similarly, we have this data for food type 3 and food type 4. Also, the minimum daily requirement of proteins is 800. Similarly, fats 200 and carbohydrates 700. So formulate the linear programming model for this problem. Okay. The problem is that how much units of food type 1, the units of food type 2, food type 3 and food type 4 to be taken, okay, or to be purchased, so that a person gets all the necessary nutrients, these three nutrients, proteins, fats and carbohydrates, in the desired quantity, okay, and with minimum possible cost. So objective here is minimization of the cost, okay. At the same time, the person has to get all the necessary nutrients, okay. So coming to the solution of this problem now. Formulation of LPP. Let x1, x2, x3 and x4 denote the number of units of food type 1, 2, 3, 4 respectively. Objective is to minimize the cost. So the cost is, cost of 1 unit of food 1 is 45, and if x1 units of food 1 have to be purchased, then the total cost will be 45 x1. Similarly, we can have the total cost of purchasing x2 units of food 2, that is 40 into x2, and similarly 85 into x3 and 65 into x4, and the sum gives me the total cost of buying or purchasing or having x1 units of food 1, x2 units of food 2, x3 units of food 3, and x4 units of food 4. Now, what are the constraints or the restrictions? These are the for proteins. We can see from the previous table, okay, that proteins are available 3 from food 1, 2 from food 4, 8 from food 3, and 6 from food 4. Okay. So, and the minimum possible intake should be 800. So 3 into x1 plus 4 into x2 plus 8 into x3 plus 6 into x4 This will be the total intake of proteins from the x1 units of food 1, x2 units of food 2, x3 units of food 3, and x4 units, x4 units of food 4. So that's why it is written over here. Okay, and this must be at least 800. So for at least is greater than equal to sign is written. Similarly, we can have the constraints for fats. Okay, on the same way we can write it. Similarly, we can write the third constraint for carbohydrates, and x1, x2, x3, x4 all are greater than equal to 0 because negative quantities cannot be purchased. Okay, so this is only the feasible options are only x1, x2, x3, x4 greater than equal to 0. Next is, now I am discussing a second problem, second optimization problem, which can be modeled with the help of linear programming models. Okay. The Agro Promotion Bank is trying to select investment portfolio for a cotton farmer. The bank has chosen a set of 5 investment alternatives with subjective estimates of rates of return and risk as follows. So this is the data given. Investment, there are 1, 2, 3, 4, 5. 5 alternatives. Okay. So, okay, if the investment is done in tax-free municipal bonds, then there will be 6% rate of return and the risk factor would be 1.3. Similarly, we have this data on all these 5 instruments of investment. Okay, the bank officer in charge of the portfolio would like to maximize the average annual rate of return on the portfolio. Okay, so here the objective function will be of maximization type. Okay, however, the wealthy investor has specified that the average risk of portfolio should not exceed 2. So the average risk should not exceed 2. It should be, or it must be less than equal to 2. This is the constraint. Okay, and does not want more than 20% of investment to be put in real estate, because in real estate the risk is very high, 2.7. So he wants that not more than. So again, the investment in real estate, that should be less than equal to 0.20, that is 20%. Okay, so formulate the LP for this problem. So now we have gone through the whole scenario, and we have now identified that what are the possible constraints and what is the type of objective function. So let us go to its solution. So representing x1, let x1, x2, x3, x4, 5 be the proportion or fraction of portfolio allocated to investment type 1, 2, 3, 4, 5. Okay, so whatever money he has, that has to be allocated in these 5 uh, instruments, in these 5 investment types. Okay, uh, proportionately. Objective function is the to maximize the annualized or annual rate of return on the portfolio. That is, if Z denotes the objective function, then maximize Z is equal to 0.06 x1 plus 0.08 x2 and 0.05 x3 and so on. So this can be seen just from the table here. Okay, so these are the returns. So this is because since these are in percentages, so I'm just writing it as 6 divided by 100, so 0.06. Similarly, it would be 0.15. So here it is wrongly written 1.5, it would be 0.15 x5. Okay, now the constraints are average risk. So this is the average of all those risk factors, and it should be less than equal to 2. And it is just simplified written just like this. So this is the constraint, first constraint. Other is on real estate investment, that is noted by x5. So x5 again should be less than equal to 20%. So it is divided by 100, that is x5 less than equal to 0.2. So then the total investment is 1, and then the sum of all these investments must be 1. Okay, so x1, x2, x3, x5, 5 greater than equal to 0. Okay, so these are the non-negativity restrictions. So this is how an investment problem can be formulated as a linear programming model. Next is very interesting example, that is advertising media selection problem. So an advertising company wishes to plan its advertising strategy in 3 different media: television, radio, magazines. The purpose of advertising is to reach as large a number of potential customers as possible. Following data have been obtained from market survey. Okay, so cost of an advertising unit: for television it is this much, for radio this, magazine this, and magazine 2 this. Now if 1 unit of television is used, the number of potential customer reached per unit this much, by radio this much, by magazine this much, and by magazine 2 this much. Similarly, number of email customer reached per unit are this, third row. Okay, so this is the data given. Company wants to spend not more than 4,50,000 on advertising. This is a constraint on this advertising. Following are further requirements, some more these constraints: at least 1 million exposures take place among among female customers. Number 2, advertising on magazine be limited on this. At least 3 advertising units be bought on magazine 1 and 2 on magazine 2. The number of advertising units, television and radio, should each lie between 5 and 10. So these are the different kind of constants. Now we have to write these mathematically. We have to write a mathematical model. Okay, how do we go ahead? We will first define the variables. So x1, x2, x3, x4. Let these denote the number of advertising units to be bought on television, radio, magazine 1, 2 respectively. Our objective is to maximize the this number of potential customers reached. So from the previous table, from this data, these are the number of customers reached. So this into x1 plus this into x2, and this into x3, and this into x4, that is this one. This will be my total objective function. Okay, now constraints on advertising budget. Okay, so advertising budget, total budget. Okay, so totally here we can see, here I can see, here this is the budget cost of this. So 30,000 into x1 plus this into x2 plus this into x3 plus this into x4. It should not be more than 4,50,000. So it must be less than this. So this is less than this. This is simplified from this, written like this. Okay, now on female customers reached by advertising campaign. So again from the this female customer, so this into x1 plus this into x3, this into x3, and this into x4, and what is the constraint on this? Yes, this is 1 million. So at least, so it should be greater than 10 lakhs. Greater than 10 lakhs here, you can see. Similarly, expenses on magazines. Okay, there is a constraint here on magazines. Yes, the total expenditure should be limited to, so less than equal to 1,50,000. So these are the magazines: 15,000 into x1 plus 10,000 into x2, less than equal to this. So it is here. Similarly, number of units of magazines as given, that on magazine 1, okay, should be at least 3 units should be bought, and for magazine 2 at least 2 units should be bought. So these are the constraints pertaining to those. Now coming on the number of units on television, okay, as given television and radio, they should lie between 5 and 10. So for television, x1 is the variables, or at radio, x2 is the variable. So these are the ranges, or these are the limits. These can further be written like this. So this is the linear programming model for this media selection problem. It can be solved by using the usual methods of solving LPPs, and the values of optimal values of x1, x2, x3, x4 can be obtained. So thank you very much. This is what I wanted to discuss in this